everybody, this is MoQuant, and today this is going to be my first machine learning video, and I'm going to be using PyTorch in it. I've also got my notes right here. So yeah, let's get started. So I'm going to import the following libraries. I'm going to import NumPy as MP, import pandas as PD, and import torch for PyTorch, import torch.nn as nn, and import torch.optim as optim. So yeah, let's go ahead and run this to make sure they're all correct. It's loading. Okay, so yeah, all these libraries are installed, so we're good to go. So the first thing I'm going to do is define a variable called data equals pd.read csv apple.csv. We're going to be working with Apple. Okay, so we've got our data frame loaded. Now we're going to extract the close prices, so that's just going to be data adjusted close dot values dot to list and reverse it because we want the oldest date to be first and the newest date to be last. So now what we could do is come here and, well, actually I forgot to import something. I'm going to import matplotlib.pyplot as plt. So I'm going to define that later though. The first thing I want to do is construct the training and testing sets. So in order to do that, I will define train test takes an argument of x and a parameter of prop, which is equal to 0.7. So 70% of the data will be training and 30% of the data will be testing. So we're going to define I equals the int of prop times length of x. So train equals x I, test equals x I. And then just return train and test. So I'm going to come down here and do train test equals train test close. And what I want to do now is print the length of train and the length of test. So 881 days is the training set and 378 days is the testing set. I'm going to increase the proportion of that to 0.85. Yeah, this looks much better. So now what we have to do is define the, so now we have to create the inputs. So that's going to be inputs, and it takes the argument of data set, and I believe it'll just be that. So window, oh right, we have to write parameters. So window is the price window that it trains on, so that is going to equal 100. Output is going to equal 30. So we're predicting 30 days into the future, and I think that's it for now. So it'll be, so n equals length of data set, and it's going to be while, or no, not while, for w in range, window hang on, let me see in my notes how I did it. Oh, okay. So yeah, we're right. So it's for range and window, and window plus no n minus output plus one. Okay. So I'm going to define a variable called p, which is going to equal um, data set w minus window and w, and o is going to be the output. It's going to be data set w plus output. Okay, so let's go ahead and print p and o. So in order to do that, I'm going to come down here and do inputs train, and then just run it. Okay, so these are running well. Shit, my computer froze. How do I close this? Shit, I guess I have no choice but to let it finish, or else it's gonna make me close Python as well. But all right, all right. I'm just gonna force close this. Okay. Now I'm gonna come here and reopen that file. We haven't even gotten to the machine learning part, and this thing's already crashing. Doesn't look like a good sign. So okay, we did that. Now I'm gonna create a new variable called training data, and when I come here, I do training data dot append. Um, so that's p. Yeah, p and o. Okay, so the training data is going to be built. We don't have any other inputs because the model that I'm looking at that I made has like a lot of inputs in it, so I'm trying to see how to like get it to work on this. But we can come over here now and create a variable called in equals torch.tensor item 0 um, d type equals torch.float 32 for item in training data, and the next one is going to be torch.tensor item 1 d type equals torch.float 32 for item in training data, and then we return in and out. Oh wait, we have to do torch.stack. Okay, so I'm gonna call this big X and big Y equals inputs, and let's take a look at what these look like. Okay, so it's a PyTorch tensor. Um, so that's how we're gonna be able, like, we have to specify the data type of it to be able to use the machine learning model. So now we got the training and the testing. I mean, we got the training. The next step is to we go down here. Okay, so now this is where we do for epoch in range epochs. So actually, let me go ahead and define some parameters. So epochs equals 2000, window equals 100, and output equals 30. So we have train test, and here the window equals window, and output equals output. So now it'll simply be outputs. Oh wait, we have to define a model. So our model will be called class model nn.module. So we're defining the neural net. So it'll be init self window, but this is going to be a different window, and output. So self.layer1 is going to be nn.linear. Window 250. Self.layer2 is going to be nn.linear of 250 to 100. Self.layer3 is going to be nn.linear 100 to output. So we're not going to make this too complex. I'm going to also define the relu function, which is the activation function, and it allows to do the underlying math in order to optimize for a certain model. So relu is going to be nn.relu, and then I come here and do def forward self and x. So x equals self.layer1 x equals self.relu x equals self.layer2 x equals self.relu x, and x equals self.layer3 x, and return x. Okay, so we have our model coded. So now what we got to do is come here and we add some more space here. So it'll be outputs equals model x. So we have to also create criterion, which equals nn.mse loss. This measures the loss error. Optimizer equals optim.atom. Oh, I have to declare the model first. So it'll be model equals model of window. So the integer of window, because that's window, and integer of output. Okay, so we've got that. So now it's model.parameters. Oh, I also forgot learning rate, which is going to be 0.0001. So LR equals learning rate. Okay, so we've got that now. It'll be loss equals criterion outputs and the actual output, and then optimizer dot zero grad. So this is performing gradient descent in the neural network, which is the optimization process that machine learning uses to learn data, and then loss dot backward, and then resetting with optimizer.step. So for each epoch, it's going to print epochs left which is epochs minus epoch. Let me see if okay, so it's looking good, and then so now we have to take the outputs, so def outputs data set. This is where we're going to pass our testing model and our window. We don't need output for this, so this will simply be I'll call this x equals data set negative window, and then how should I do this? So I'll call this x again equals torch.tensor of x. Oh no, it'll be x and d type equals torch float 32, and that's the only one. So we would do return torch.stack x with a comma to indicate the tuple. It's not just parentheses. So we train that model, and then we do xx equals outputs test window, and then we do with torch dot no gradient, because we don't want to train this any further. It'll be test outputs equals model of xx. Let me just double check with my notes. Okay, yeah, I did the right thing. So now what I have to do is, let me come back. Okay, so I could do. Wait, where'd it go? Okay, it's right here. So this would be predictions equals test outputs -1 to fetch the latest row dot numpy that to list. So now that we have these, we could do well, actually, let me return an x over here as well. So xx and ax. So predictions and ax. I'll call this actual. Yeah. So these are the actual prices. These are the predictions. But the thing, well, no, because we're forecasting it into the future. So I'm gonna just call this history. So now what I'm gonna do is I'm gonna write. Well, now let's see. Let's just run it. Let's run the whole thing and see how it works. Oh, I forgot. I have to declare it. So super model self dot init. Okay, so it's training the model. But the print statement makes it like slower. So I'm gonna do something to like curb that a little bit. But right now I just want to see like the raw output that we get of this, just to make sure like there's no errors going on. So far, I mean, PyTorch seems to be working, so So almost finished training. And actually, like after this portion, I'm going to make some additions to the data set that we can use. It's still taking a minute to like load all of this, so yeah, but it's almost done now. I know I said before it's almost done, but now it seems to be almost done. Okay, so we got our predicted prices here, so everything went well. And what I mean right now by what I'm going to say is I'm going to come here and do if epoch plus 1 mod 100 equals 0, so it'll print only every 100 epochs. Okay, so we got our predicted prices, and before I do anything else with this, I'm going to add additional inputs to this. So when we load the data set, we want to have 3 columns, not just one. So I'm going to create a function up here called add metrics, and it takes the argument of x. So I'm going to actually go ahead and call it here before I even call model. I'm going to do add metrics close. And I'm going to set a look back period here. Or no, I'm going to call it days equals 50. We want a 50-day moving average and volatility measure. So I'm going to define this as data set, and then I'm going to do for I in, wait, let me take the length of x. So that'll be for I in range days, and we'll define box equals x I minus days I, and then MA is going to be the moving average of x, and the standard deviation, I'm going to do the Bollinger Band. So first I'm going to do standard deviation equals numpy.std box. So low is going to equal MA minus 2 times SD, and up is going to equal MA plus 2 times SD. So I'm making Bollinger Bands in this, and it's going to be data set dot append x sub I moving average, low, and up. So I'm going to return pd.dataframe. So that's data set columns equals price, moving average, lower band, and upper band. So let me go ahead and comment these out for now. I want to make sure like this data frame comes back, so I'm going to call it df equals that, and then it's going to be print df. Okay, so yeah, we've got our data set now with the moving averages and lower bound and upper bound. These will help like detect patterns in the data. So now I would have to do, since we have 4 variables, this has to be multiplied by 4. So it's going to be int window times 4. And then output's going to stay the same, but this time in train test, I'm going to pass in the data frame, and let me go ahead and make sure this is also correct. So that'll be print train and print test. Okay, so yeah, the data set has been successfully splitted, so I don't need these comments anymore. Now, so when I go to inputs, yeah, inputs right here. So in order to do this, so it's gonna have four variables. So instead of calling it that, I'm gonna call it A1, A2, A3, and A4, which is the NumPy array of this transposed. And our output will also have the same thing. So I'll call this B1, B2, B3, and B4, which is the NumPy array of data set transposed. And now our training data, well, actually, that's why I'm going to add a .to list here again. So .to list, and we're now going to do A1 plus A2 plus A3 plus A4. And then here it would just be B1, just because we're trying to predict the price. So we would keep the ins and outs the same, but when I come here for this, I'm going to do the same thing. A1, A2, A3, A4 equals NumPy array of this dot transpose. So this is going to be A1, A2, no. A1 plus A2 plus A3 plus A4. Let me just check my notes real quick. Shit, where to go? Okay, yeah, I think I did have it right. So it's simply just merging all these lists together. So dot to list. So instead of here, I'm going to do return A1 for the price. And now I'm going to do this again. So print, no, predictions. This kind of goes faster because the last time it trained without even having like this much inputs, it did not go well. Okay, so we have the predicted prices. So now we can plot it. So I'm going to come here and do import matplotlib.pyplot as plt. I already called it up there. So I'm going to name a figure. So that'll be plt.figure, fig size equals 9 by 5. AX equals fig.add subplot 111. So now XA is going to equal list range length of history. So AX dot plot XA and history and color equals red. But XB is going to be list of range length history to length history plus length predictions. So ax dot plot. Oh yeah, let me add a label. So label. So that's historical, and this is going to be the predictions, and plt.show. So let's see how this turns out. Let's go ahead and let me just. Wow, there we have it. This is our predicted stock forecast for Apple. It's saying that it's going to keep on going up, but it doesn't seem too volatile. Like it's within the $185 to $190 range. So maybe it could perform like that tomorrow. We never, well, not tomorrow because tomorrow's Sunday, but maybe on Monday it could do it. But we can see how volatile it was before. So it's surprising to see that it didn't get like too many like volatile predictions in here. But yeah, I mean that's pretty much it. We also put in the moving average and Bollinger Bands in it to like sort of gain a pattern of what could happen. But yeah, overall, I think we did good. I thank y'all for watching my video, and I'm gonna keep posting a lot more of this kind of content from now on. So, peace out.